Today, we're diving into a really exciting new research paper about an AI model that could completely change how doctors predict the path of cancer. It's called M4Survive, and it's all about giving AI a much, much fuller picture of the disease than it's ever had before.
So here's what we're going to cover. First, we'll look at the big problem in cancer prediction. Then we'll unpack the multimodal solution that M4Survive brings to the table. We'll peek under the hood to see how it works, check out how it actually performed, and then talk about what this all means for the future of cancer treatment. All right, let's start with that puzzle. To treat cancer well, you first have to understand it. And that is an incredibly complicated task. This right here is the central question. Every single treatment decision hangs on the answer. Getting an accurate prediction about how a tumor is going to behave is absolutely crucial for picking the right therapy. The problem is, tumors are just wildly complex, which makes this prediction game incredibly difficult. Right now, doctors basically have two main ways of looking at a tumor. On one hand, you've got radiology. Think MRIs, CT scans. That gives you the big, zoomed-out picture of the tumor structure. And on the other hand, you have pathology, which zooms way, way in to see the nitty-gritty cellular-level details. And that's really the heart of the problem. If you only use one of these, it's like trying to understand a whole city with just a satellite map or just a few photos from the street. You get some useful info, for sure, but you are totally missing the full story. The real truth of the tumor is somewhere in the connection between that big picture and all those tiny details.
So, this leads us to the big idea behind M4Survive. If one view is good, and two are obviously better, what if we could teach an AI to see and understand both at the exact same time? This is where a concept called multi-modal AI comes in. The whole goal is to fuse data from these different sources, in our case, the radiology and pathology images, to create one unified understanding. It's a fantastic idea, but, in the real world, past attempts have hit some pretty serious snags. For starters, just trying to process these massive datasets and connect them was a huge computational nightmare. These older models also kind of fell apart in real clinics where, let's be honest, it's pretty common for a patient to be missing one type of scan. And on top of that, the early methods just weren't very smart about capturing the really complex, dynamic relationship between the two views. So the big question is, how does M4Survive actually get around all of these problems? Okay, let's pop the hood and see how this new engine actually thinks. It all starts with something called foundation models. You can think of these as giant AIs that are already world-class experts because they've been trained on millions of specific images. M4Survive basically uses two of these specialists, one that's a pro at reading radiology scans, and another that's an expert in pathology slides. So here's the four-step process. First, those expert models look at the images and basically summarize them into a compact numerical code called an embedding. Then, and this is clever, the system translates both of these different codes into a single shared language that it can understand. Then comes the magic step. It fuses these insights together. And finally, it uses that combined super rich data to make one single prediction about patient survival. The real secret sauce here, the thing that makes it all work so well, is a component called the Mamba adapter. Think of it as a super efficient, super intelligent translator. See, older methods would create these huge computational traffic jams, but the Mamba architecture is lean and mean. It's specifically designed to find and hang on to all the subtle, important connections between the two data types, and it does it really, really fast. Okay, that all sounds fantastic in theory, right? But the real question is, does it actually work any better than what we had before? Let's look at the results and see how M4Survive stacks up against the competition. The metric we care about here is called the C-index. Just think of it as an accuracy score. The higher the number, the better the prediction. And, well, when you put M4Survive head-to-head with other top models, it's not even close. It comes out on top by a really significant margin. Let's just zero in on that number for a second. 81.27%. This isn't just a tiny improvement. This score represents a new state-of-the-art. It's a whole new benchmark for how accurately we can predict cancer survival using this kind of imaging data. So why is it so much better? Well, the researchers say it comes right down to the design. This quote from the paper pretty much says it all. The Mamba adapter's special ability to capture those really subtle, fine-grained connections between the two views is what gives it the edge. It proves that how you combine the data is just as important as what data you're combining.
And to prove this, they ran tests where they basically swapped out different parts of the model to see what would happen. And the results were crystal clear. The two essential ingredients for success were, number one, using those expert foundation models, and number two, using that super efficient Mamba adapter to fuse everything together. You really needed both to get these results.
Look, this is about way more than just setting a new high score for an AI model. This kind of breakthrough has massive, real-world implications for how we treat actual patients.
And really, this is the reason this all matters so much. It's pushing us closer and closer to an era of what's called precision oncology. That means we're moving away from these one-size-fits-all treatments and toward plans that are custom-tailored to a patient's own unique tumor biology, a biology that we can finally see in its entirety. So if we boil it all down, M4Survive really brings three huge things to the table. It gives us a new, smarter way to fuse different kinds of data. It delivers a proven major jump in predictive accuracy, and maybe most importantly, it's built to be scalable and efficient enough to actually be used in a real hospital, not just a research lab.
And that kind of leaves us with this final, really powerful thought. We're not there tomorrow, but this research shows us a clear path forward. We're getting so much closer to a future where AI isn't just a lab tool, but a critical partner in the fight against cancer, helping doctors build a truly personalized battle plan for every single patient.